So next one we're going to do is sine law. So to remind you of sine law, I'm going to label the triangle. So the way that we labeled the triangle was we have on the corners, and this is why I was saying about the capital versus lowercase. Capital and lowercase for math is different things. So we usually do capitals on corners, right, on vertices, and then we say to the opposite when you're pointing to this length here is lowercase a. Does that make sense? So we do capitals for vertices, usually corners, and then the lowercases, we're saying it's that length there. So that's how the formula works when we wrote the sine law, right? So that's capitals and lowercase aren't interchangeable. So if you did a capital A here, that would look really wrong. Does that make sense? So don't try not to interchange capital and lowercase in math classes. So here, across from here, that side length AC would be the side length B. Okay, and then this side here, across from C, would be a lowercase c. It's hard to see a lowercase c versus a capital, but it's a little smaller. Okay, like that. So that's how we label a triangle. So we've got the A, B, and C, and we've got that. So we've got the law of sines. We have A over sine of A. It's a ratio. So think of it this way. This side length is going to be in ratio to how big the angle is. So if my angle is small, the side length, so if this is the side length, this lid here, my angle will be small, right? So my angle here, this would be small because I'm holding that. If I'm holding the whole pen, that angle will be bigger. Whoops, let's go out. Right? So if I'm holding the whole pen, my angle would be bigger. If I'm holding a shorter side, my angle's smaller. So they're saying that the angle here is related to the side length here. The angle C is related to the side length here, and this angle B is related to that side length because it's holding that side length. The angle holds the side length. So the longer the side, the bigger the angle. So that's where the ratio of the sine law came from. So it's not just the angle to the side, it's sine of the angle. Sine of the angle related to the side length. That's where they came. You can write the ratio upside down or right side up. People consider it either way. So these are exactly the same ratio. Right? So if I say it's the ratio of A to sine A, it's the same thing as sine A to A. Right? It's the same thing. Okay. Cosine law, same thing. We've got the sides. So we still, capitals are for vertices, and side lengths are the shorter, are the lowercase. So this would still be side length B. That's side length A, and that's side length C. Does that make sense? So lowercase. So again, that one. That one. So that's still how we label it. Then we have the law of sines, cosines. The law of cosines reminds you of kind of Pythagorean theorem. So a squared equals b squared plus c squared minus 2bc, it matches bc, cos a. And this angle always matches this side here. That's the way I remember it. And then the three versions. So lowercase a matches the capital A here. Okay? Yes, you have to memorize these formulas. So yes, you do. Yeah. The other cosine law is when you solve it for the angle. I don't memorize that one. So if you want to, you can. Right? But we can put that on another page. I don't memorize it. I memorize it this way, and I solve. Yeah, so I solve for it. So the other cosine law, it's not really the other cosine law. What they do is they solve for A. So they bring this to that side, bring the A over, and divide both sides by 2bc. Right? So it's the same cosine law, it's just solved for A. Yeah, yeah. So it's the same law. I don't tend to memorize two of them. I just memorize one and then solve, right? Because I know how to bring this over. When it comes over to the other side, it becomes 2bc cos A. When this comes to this side, it becomes minus a squared, right? And again, you're not to write the formula on yourself, on any Post-it notes, on your calculator, nothing. You can't bring the formulas into a test. Yeah. Okay. Find the length of R to the nearest hundredth. Okay, I'm going to highlight that. Hundredth is 2, right? 2 decimal. So stop me if I'm wrong. 2 decimals, right? This time. In the triangle PQR, so that symbol there is triangle or delta, but it's triangle in this case. Angle Q is 90. Angle R is 42, and Q is 10 meters. So then I'm going to draw the triangle. So I usually just draw a triangle. Any triangle at all, so I'm going to go 90, that's Q. So I start with one of the angles. So I know that's Q. Angle R is 42, so I'll just do any triangle right now. So 42, R is 42 degrees. And Q is 10 meters. So Q is 10 meters. So QR, if it's triangle PQR, the one that's missing is P. Yes? Right, so based on the words there and the information there, I should be okay. So PQR. Then, so I know that's P. Q is 10. Q is opposite Q. So this is 10. There's 10. That's length is 10. There we go. I want to find R. So R is opposite R. So this side is R. That makes sense? Okay. Knowing I have 42, I know I can find the missing angle because 180 minus, right? 180 minus 90 minus 42, we're good. But I'm going to use the 42 because they gave it to me. Why bother finding another one? So then from this side, I know that the side over here, this one's the opposite. Again, you don't have to write this, but for yourself. And this one is the hypotenuse. Okay, that's my brain thinking O and H. If that's O and that's H, right, you don't have to write it, but if it helps you, then O and H based on SOHCAHTOA means I'm going to choose the SO part of the SOHCAHTOA. So then I'm going to write sine of 42. Okay, so, right, again, not capital for the sine, try not to, equals, and opposite is R, and the length is 10. So if I'm solving for R, I just need to bring the 10 up. So I'm going to just multiply it up there in front. Do you need to show me this step? No, you don't. So you can go right ahead. So watch. I want to see this step. Show me the ratio. And then if you want to calculate this on your calculator right away, you can go 10 sine 42. Other than that, don't skip any more. I don't know what else you would skip. So this would be, what do you get? 6 point, and I want hundredth. So I got 6.691. Hundredth is 2 decimal. So this will be 6.69 is approximately R. Do I have units? Units? Meters. So meters, so let's remember that, so meters. Okay, so just make sure you put the meters right there. You can put it right at the end. If it's a sentence, do a sentence, but this one doesn't require a sentence. Okay, triangle DEF. Angle F is 35, 42 for F, and D is 64. There is no right angle here. People, after they do a bunch of these, they automatically draw a right angle. Nothing in this tells me it's right. Solve the triangle round. So don't automatically draw right. Unless they tell you it's a right, do not draw a right angle. Did it say anything? No. Okay, it says it's an acute triangle, nothing of that. So 35, 42, 64. Okay, so then what I want to do is draw a 35, and we're going to just draw a little acute angle. So 35. So 35. So I'm making it small. That's angle F. F is 42. D is 64. So I'll just drop it here. I don't know where to drop it, wherever. So I know that this one's 35. Then I'm going to label the rest. So angle F is 35. F across from F is 42. D, do I know anything else? DEF. DEF is the triangle. DEF, so DEF. Right, I don't know anything else. D is 64, so I'll do 64 here. Good? That's all I have. Anything else? No. Okay. I want you to solve the triangle. What does solve the triangle mean? Do you remember? Yeah. Everything. So that here means find everything that's missing. Find every angle inside that's missing. I'll say that's missing. Right? Because we already have some. So if it's missing, we want to find it. Okay? So this means find every angle and side that's missing. So that's what I'm thinking in my head. Oh, you want me to find everything that's missing? Yes, I do. So we're going to find everything that's missing for this one here. And we've got this. Round to the nearest meter and degree. Round to the nearest meter and degree, nearest degree. Okay, so always read that stuff. And we need to know if we're going to use sine law or cosine law. So first of all, no SOHCAHTOA. SOHCAHTOA is only allowed for 90-degree triangles. No 90-degree, no SOHCAHTOA at all. Don't even think about it. Not allowed. Which would you like to use?
Can we use both?
You can't in this case. There's not enough information to use it for...
No, I mean, if we find this first angle,
Mm-hmm.
and then we can use the cosine law.
Yes, yes.
So,
Yeah, so how would you find the first missing one, though?
Which one is the E?
I don't know. We can start with anything. I'm missing 2 angles and a side, right? So I'm missing this one, and this side. That's what I have to find. I have to find everything that's missing. Can I find any of the angles? No. 35, I only have 1 angle. Can I find the side? So which formula am I going to use? Sine law, cosine law, not allowed to use SOHCAHTOA. It's sine law or cosine law. Yeah. Yeah. What did I say about sine law? It's the ratio between I can hold that side and I'm holding the angle. So when you can do this and you've got the side and that's the sine law. You're holding it right there. That's the ratio. So whenever you've got this scenario where you're holding the angle and the side, that's sine law. People always go, how do you know which one? This is sine law. When you're holding the angle and the side. So this tells me sine law. So this is going to tell me sine law. So sine law, this. That tells me sine law. Okay, when you get that scenario, yeah.
So what do you mean by like holding?
So this angle, think of it like a mouth or an opening, like if you're opening something, this 35 is holding the 42. That's the length that it's holding right there. So if I was to take like 2 chopsticks or something, right, and I'm holding it, I'm actually holding the 42 with my 35. How wide does it have to be? 35. I'm holding the 42. If you open it, you drop, right? So I'm holding it. I always think of it like this angle is holding the 42. And that's why they said the longer the side, the bigger the angle.
So like if 42 was on like the other side, like
Then it's not holding it. I can't use sine law.
Oh,
Yeah.
okay.
So that's the scenario I'm looking for, because sine law is the ratio. So once I have that ratio, that's beautiful. Yes?
So for cosine law, we'll always use like all 3 sides, right?
No.
Not always?
No. We'll go into cosine law later. That is not it. No. Yeah. So hang on a second. Okay. So for sine law, you're looking for this scenario. So I always do SOHCAHTOA, 90-degree, can't do it. I always look for sine law, and if it's not sine law, then it's cosine law. But cosine law has more than just side, side, side. Okay, yes. It has also the uncontained angle, so we'll talk about that in a minute. Yeah, so good question, but not yet. Okay, so sine law is this. Once you eliminate sine law, then it is cosine law. But sine law, you're looking for this scenario where you have an angle holding the opposite side. Does that make sense? Okay, angle holding its opposite side. So then I know that this is my ratio. Which one do I want to find first? It doesn't matter, whichever one fills in the ratio. I know it's a 42 to 35, so it's a 42, so that's my ratio, to sine of 35. That's it. That's my ratio. That is the glorious sine law ratio. Yes? No, and I showed you that before, right? So does it matter if it's upside down? No, I said no. Right? So it doesn't matter if it's upside down. Now, how do I decide? I decide on what variable it is that I want. So I want the variable here, the lowercase e, and I also want these 2 angles. So up to you which one you want to start with. If I want to start with the lowercase e, I would put my variable up on the top, e, side length, and say, oh, I don't have anything. Oh, I can't do that one. So which one would I have to start with? Angle D. Right? So you have to look and say, what can I find and what can I not? You can't just say, oh, I want to find that. What do I have? I have these two. These two made up my sine law. Does that make sense? They made up my sine law. I have 64. So the only other one I can go to, people go, can I start with anything? You cannot. So the only one I can find now is this one. Because of this, we're doing that ratio. So we're going to do 64 to D. 64 to sine D. So that would be 64 to sine D. Now, you can write it this way, or, okay, good question, upside down. I said that above. So which one would be more useful to you to write? This way or upside down? So I can do sine of 35 over 42, and both of them are totally fine. But which one would you prefer and why? Yep. Okay. Yeah. This one, the variable I like to put on top. So I usually like to choose the ratio. So they're both equivalent. They're both wonderful. But I usually like to put the variable on the top. So then when I'm solving, I just bring the 64 over. And I've got that one by itself. It still works with this. I would bring the sine D up here and crisscross it this way. Right? So you'd still cross it, cross multiply, bring it over, bring it there. This one just takes one less. You're still going to get the same steps. Right? You're still going to get about the same number of steps. It's not a big deal. Right? I'm going to go 64 sine of 35 over 42 equals sine of D. I'm still not done because that's not the angle. So to find the angle, what do I have to do? What do I have to do to find the angle? Yeah. Inverse it. So I'm going to bring the angle. So I'm bringing this over, which means it becomes the inverse. I picture it as bringing it over and then keeping this whole thing in a bracket. And I know maybe your teacher last year asked you to approximate a couple times. Yes? No? Some teachers maybe said do an approximate, a decimal, decimal. I want you in this course to not approximate it twice. I want you to keep all of this, and let's punch this all into your calculator. Let me show you how. You can do the inside of the bracket first. So you go 64 sine 35. Can you make sure you're in degrees, please? Whenever you take your calculator out of your backpack, out of your pencil case, check to make sure you're in degrees. Okay? Get the top, numerator, equals, divided by 42, equals. Keep that on your calculator. Got it? I don't want you approximating twice. So I know in grade 10, some teachers would say approximate, approximate. You're rounding too many times. In this course, I don't want you approximating twice. I want to be more accurate. Then I want you to second. So see how that's my answer for that? Everyone saw that? So 64 sine 35. I finished the top. I pressed equals. Divided by 42. Finished it, pressed equals. Then I go shift sine. And then if you press, you can you can press the word answer, which takes your answer from before. But if I just press equals, I just pressed equals, it grabs the answer automatically. So it said, oh, I grabbed it for you, and I took the inverse of your last answer. And I get 60.9, which is 61. Okay, so one more time. I did 64 sine 35, I got that. Divided by 42, press equals, got that. Then I did shift sine, and I just press equals. And it grabs my answer automatically. Some people press answer, which is fine, but if your calculator is programmed to grab your last answer. And I got 61 degrees. Yes? Do I have to write out the steps? What did I just show you, though? What did I just say? But what did I say? So you're asking me if you want me to write out the steps that I just plugged in my calculator? What did I say about that, though? Did I not say anything? What did I say?
You said you could just answer it all at once.
Yeah, and I'm showing you that on the calculator. And I said, do not write out something to the decimal, something to the decimal. I do not, 100% do not write out each step. So I don't want to see you say 64 sine 35 and get me a decimal, and then divide that by 42 and get me a decimal, and then do not, 100% do not. Good? Do not do it. No, it's an absolute no. Okay? In this class, I want you to keep it accurate. The more you round it, the worse it is. So 100% do not write out step, 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 step. If you're doing that, you're not doing what I'm saying. Okay? 100% do not. You're rounding it too many times and you will lose marks. So it's an absolute no. Which steps? This step here? Do I have to write that? What do you guys think? This one here? What did I say from above here? Knowing the steps I got here, what do you think? Do you have to write this? So I got the ratio. So what step am I marking? What do you think I'm going to mark? What step do you think I'm going to mark? Based on what I said from before. Yeah, one or this, right? So one of these two, I'm marking that. Okay? Maybe bring up one of these guys. I would bring that up to show that, right? Do I need to see you press this here? Do you think that's a necessary step? That one there? No, right? What did I say from above here? Did I need to see this? No, right? So same question? No, right? So I don't need to see the inverse press because I know you can press on your calculator. So I don't need to see this. So you're asking for this one. I don't need to see that. And same thing here, right? So the same thing applies here. If you want to go from here to here, you can do that. So on your calculator, you just press inverse yourself. Good? Yes? Were there any other steps, though? Or is that good? Okay. Right? So that one, no, because you're just pressing inverse. You're showing me the ratio, and you got that. Okay. What can I find next? What can I find next? Based on the fact that I just found that this is 61. So that's 61. I can find angle E. So angle E will be 180 minus 35 minus 61. Do I need to see this? No. So if you want to type that right into your calculator, 84. So I'd mark this. So you don't need to show this. That step there, subtracting it, it's either right or wrong. I just need to see the 84. Okay, I have one last thing to find, and that is side length E. So you're going to use your ratio, or yes, you asked, you can use the cosine law, right? So your question was, can I use cosine law? Or you can use the sine law again. So I'm going to go E sine of E, which is right here, equals, so I have 84 now, that's 84. Okay, what do I put for the rest of the sine ratio? I'm going to go back to my original, this one in purple, and I have this original, right? That's the mouth that I had the ratio here. So I know that it is still 42 to sine of 35. That is my original ratio. So we're going to use that twice. If you write it this way, look, with the variable on top, it's easier. So my suggestion is try to write it with the variable on top. That way I only have to bring this up. Do I need to see that step? No. I need to see this step? Yes. Set it up, and then if you want to bring it up and multiply it on your calculator, no, do not need to. Is that making sense, the steps I need? Good. So ratios, yes. The middle step, I don't need that one. I'm going to write it for you in case you want to write it. It's not wrong.